Everyone. The topic of this video is going to be the technique flow cytometry. The video presentation was done by Annette Ochoa, myself, Lily Perez, Hannah Medina, and Giselle De Leon. Now, I'm going to start by breaking down the word flow cytometry, the nomenclature, and let me just write it down with my special handwriting. Now, flow means the movement of cells. Cyto means cell, and metry means measurement or measure. Now, the flow cytometry meaning is a laser-based technology that is used to measure characteristics of biological particles like nuclei and organelles. The cell components are fluorescently labeled and then excited by lasers to emit light at varying wavelengths or voltage. Now I'm going to give a quick overview of how flow cytometry works. Excuse my drawing, I tried my best. So you start with a prepared sample, and it is placed into a fluid that moves the sample down into the laser. Now the fluid in this case is saline. Now it moves down to the lasers, and the cells pass the narrow tube, which makes the cell go into a single line, and it detects individual cells. Now the forward scatter detects the size of the cell, while the side scatter detects the complexity of it. So as you can see, it's voltage on the y-axis and time on the x-axis. If the cell is small, the voltage is going to be small. If the cell is large, the voltage is going to be big, as you can see in that graph I made. Now I want to explain that there's also optics that gather light and the different fluorescent light that is given off by the cell. And there's also light detectors that sense the light, and they all connect towards the end and is sent to a computer, a CPU.
Lily previously mentioned how the flow cytometer determines the size and amount of cells in a sample using the scatters. And now I will be talking about how does it measure the size and the density of the cells using fluorescence. The cell samples are first prepared by dyeing them with a color. And this is done by staining some of the antibodies that are on the surface of the cell. So here I'm drawing the cell in a ground state, and it's already stained. And then the cell is treated with a high energy blue light. So here I'm trying to attempt to draw how the light excites the cell. The blue light is the high energy, and then the cell emits a lower energy green light. So when the excited cell goes back to its ground state, it emits this green light. So here I'm just gonna draw like a little diagram for it. So the absorbed light is the high energy one, which as you can see, it moves the cell to a higher state, and then when it goes down to the ground state, it emits a green light that is then read by the detectors. So this all happens in the cell cytometer, and as Lily explained, it has a bunch of detectors with which the light goes through a bunch of filters that differentiate the different light. So here is how it detects both the strong and the lower energy level light, and then the CPU gathers all the information and puts it in data sheets for the scientists to read.
Flow cytometry is mainly used in the clinical laboratories due to its unique characteristics of cell analysis. Application of flow cytometry can be applied to the study of cancer, evaluating peripheral blood, bone marrow and other body fluids. In the University of Pontificia Javeriana in Colombia, along with the Hospital San Ignacio, started with the study of stabilized body fluids using flow cytometry. The application of flow cytometry was established in 2008 in the study of several blood fluids. Some of the samples studied in those institutions were samples of patients with hematological malignancies and solid tumors. According to the article of study of blood samples using flow cytometry, this study defined several of the main findings samples evaluations over a 6-year period. Throughout that period, 1,070 samples were examined by the application of flow cytometry that included body fluids from patients with malignant diseases. These samples included cerebrospinal fluid, acid fluid from acute and chronic leukemia patients, and others. During the study, about 900 cerebrospinal fluid samples were studied. Researchers in the study explained that the most pathological conditions identified were infiltrated by B cells, acute lymphoblastic leukemia, with 50% of the cases. After the application of flow cytometry, the researchers revealed that of all the samples that were tested in the period, 90% demonstrated tumor infiltration and the remaining 81 were cell tumor-free. The patients with positive tumor infiltration had the cerebrospinal fluid show a higher number of total cells, which included T lymphocyte and monocyte. Using flow cytometry, the researchers concluded that the application of the tool detected a minimum number of tumor cells. This finding was important because flow cytometry has become essential in the classification and detection of minimum number of tumor cells in leukemia and lymphoma cases, among others. As claimed by the researchers in the article, flow cytometry has a significant contributed in the detection of tumor populations that have invaded different tissues.
Hello, my name is Hannah Medina, and today I'll be talking about immunophenotyping with flow cytometry, and this is my assistant Dexter. The first step is the prepared solution will go through a saline solution stream in the flow cytometer and will go down a single file line channel into a laser beam. The laser beam will detect the forward scattered light by detector and will be converted into a voltage pulse. The side scattered light will also be detected by another detector and will be converted also into a voltage pulse and will determine the shape, size, and complexity of the cell. The cell can also be determined if it has any fluorescent dyes and or color stains by the fluorophores at the top. The fluorophores can either detect one color or up to 4 colors. There are also some flow cytometers that can detect up to 18 colors at a time. The purpose of the flow cytometer in immunophenotyping is to detect the diseases leukemia and lymphoma. The samplings needed are blood sample from an arm vein, bone marrow, tissue biopsy, and fluid. The use of this is to determine the effectiveness of a treatment, to check for reoccurrence, and detect presence or absence of white blood cell antigens.